Today I'm going to show you how simple it is to perform a whole house block load using the EMS HVAC load calculator. Here at the upper left hand corner you will enter your company information. Over on this side you will enter your client's information. Now, that's pretty much self-explanatory. Now let's go ahead and get into the meat of the calculation itself. So have number one, we want you to enter the design conditions. The design conditions, unless otherwise required, let's say, or if you want to change it. For the indoor, you want to have it 70 degrees for the winter time, and for the summertime, you want to have it 75 degrees. The outdoor design temperature depends on where you live. If you have access to a manual J, or you could just Google if you want the outdoor design temperatures for your area. We're going to use the Raleigh, North Carolina area for this demonstration. So in this case, the outdoor design temperature for the winter is going to be 20 degrees. That don't mean that that's the coldest it ever got in history. It's just typically how cold it will get in Raleigh, North Carolina. And for the summertime outdoor design temperature, we're going to use 95 degrees. Now again, we know it's got to be 100 before, but that's only 1% of the time. So we want to use what would be a typical hot day. Then we come over here and we enter which direction the house is facing. So let's just say it's facing east. And then we're going to enter the total condition area of our house. So let's just say that our house is 2,000 square feet. So we're going to put 2,000 square feet in there. Next thing is asking for the humidity. It is moderately humid in the Raleigh area, so we are going to put moderately humid. And you see this 40. That means that we got to remove 40 grains of moisture for every pound of air. The next question is, how tight is the structure? Well, the house is 2,000 square feet, and let's just suppose that is a new house. If it's a new house, it's going to be very tight because the code requires you to insulate it very well. So we'll say it's very tight, over 1,500 square feet. And this will give you your winter air changes. Now, if you happen to have your blower door results, then you can enter whatever those results are. 0.2 air changes and 0.1 air change for the summer. But in this case, we're not going to do that. We're just going to say the house is very tight and over 1,500 square feet. If you've got a fireplace in there, let's say I've got one fireplace in the house and it's very tight, so just leave it very tight. The next question it's asking you is the number of occupants. Let's just say this is a 3-bedroom home, and so we say that generally that equals the number of bedrooms plus 1. So 3 plus 1 equals 4 people should be in that house. Then we go to the next step. The next step is going to ask you some questions about your windows. Here at the top, it's asking you for overhang characteristics. And the reason we're asking for that is because that overhang right here is going to shade that window. And we're going to, this calculation right here will determine how much of the window is shaded and how much of the window is not shaded. So let's suppose that with our house that facing east, the distance from the top of the window, from the top right here, to the overhang is 1/2 foot. We're going to put 0.5, and you always put in a decimal. If it's 6 inches, it's 0.5. If it's 4 inches, it's 0.33. So always use a decimal. On the other side of the house, we've got an overhang, and that's going to be 0.5 inches. Will be 0.5 foot or 1/2 foot from here to here. Next question here is, what is the length of the overhang? In other words, how far does it stick out? And let's just say that it sticks out 1.5 feet. Again, decimally, 1.5 feet. They're saying, what's the total linear feet across the top of the windows located below the overhang? So what we want to do is you want to look at the linear feet across all the windows. This sample up here shows you there's 3 feet, there's 5 foot, and there's 3 feet. But let's just say for our sample house that facing east, the linear feet across the windows is 12 feet. And facing west, the linear feet across all the windows is 18 feet. And we don't have an overhang facing south or southeast or southwest or northeast or northwest. So we just leave that blank. Now we'll come on down here. If you have the manufacturer specs on the windows, you will check this box right here and you will enter your latitude. For Raleigh, it's 35 degrees. You get the U value from the manufacturer specs for the window. In this case, you're going to say 0.30, and the SHGC, that's the heat gain, the solar heat gain coefficient. We're going to say that's 0.35. And if you see right here, it gives you automatically calculated your HTMs. Well, if you don't have this information, then uncheck this box, and we will instead select the type of glass the window has. And it's going to give you some generic numbers. And if you don't have the information above on the specs, you're just going to have to be using those. So let's just say they're all double glass. So with this particular house, let's say that we've got 54 square feet of glass facing north. We've got 64 square feet facing south, 34 facing east, and 58 facing west. Okay? Now, this is telling you that the total solar gain, this is the heat coming through the windows, is 9,662 BTUs. If the glass has got reflective coating, you can click yes, and it's going to drop your BTUs down. Now, one word of caution: if you selected use the manufacturer's specs, then do not select yes for reflected coating, because that's already in the manufacturer's specs. Now, if you have any skylights in this house, let's go back. Well, we leave that where it is. Let's go back here and say we got 8 square feet of glass skylight. And let's say it's tinted. It's telling you that we've now got 800 BTUs coming through that tinted skylight. So we got a total solar gain of 5,630 BTUs. Next question is, they're asking is, where's your ducts located? Well, let's say that these ducts are located at a trunk and branch in the attic, with air conditioning and heating ducts are in the same place. It's a new job, so your duct insulation is going to be R8. The duct leakage will be sealed. The area of the attic or floor where the duct is located. What we're asking you therefore is, how big is the area that the ducts are laying on? In this case, if it's a 1-story house, the house is 2,000 square foot, so the ductwork is sitting up there in a 2,000 square foot attic. So we put 2,000 square foot. The attic temperature, that is something you're just really going to have to guess at. And so I'm going to put 120 degrees. If you're out there in Texas, since it's 110, with a tin roof on there, you might want to put 150 degrees. So that's going to be your best guess. By the way, a load calculation isn't much more than really a best guess, but a pretty accurate guess. And now we're going to go to the next window here, and this is going to be basically the load calculation itself. If you'll notice, it carried over the heat gain for the glass, which is 5,630 BTUs. We're going to put in the gross walls. This is the perimeter of the house times the ceiling height. So put 1,860 square feet, and it's already put your glass area in here, skylight. We've got 2 doors in this house, which is a total of 42 square feet, and then the ceiling is going to be 2,000 square feet. And we're going to put this house as over a crawl space. It's got 2,000 square feet of floors. I want to bring to your attention that if the house was on a slab, we wouldn't put 2,000 square feet. We've got to put the linear feet. So whatever the perimeter is around the house, that's what you would put right here where it's asking for slab on grade. And for infiltration, it's asking for the cubic foot of the house. Well, the house has got 9-foot ceilings, and that's 2,000 square foot, so it's 9 times 2,000. That's your area times your ceiling height. So it's going to be 18,000 cubic feet. Now we're going to go back and we're going to select all of our insulation values. Our windows are double. Our doors are insulated. Our net walls is going to be an R15. Our ceiling will be an R30. Our floor will be an R19. And now all these R values, do whatever you want, but I'm using this is a new house, and these are minimum code requirements for the area in Raleigh, North Carolina. Then we're going to come down here where it says appliances. I'm going to click that. It says enter a value. And I want you to put in 1,200. Now, if this house is something we're doing a lot of cooking, maybe use it for a catering business or so, you might want to up those figures. But 1,200 is generally what you would put in for all the appliances, for the heat that's given off by all the appliances. So here we are. We've got a load calculation actually completely finished, and it's showing that the heating load is 27,971 BTUs, and the total cooling load is 21,773 BTUs, which will be about a 2-ton unit, which is 1.81. We also have this little item right down here that says your outdoor airflow rate. The code is saying now that you've got to have mechanical ventilation from outdoor air, and that is what that's telling you, is that you've got to have 50 CFM of outdoor air pumped into that house. And you can do that with a duct running outside from your return side. So, folks, that's basically it. That's how you do your load calculation. You can come back up here, you can click right here, you can save it if you want, or you can click print report, and here comes a PDF of what you have just done, and all you got to do is push print, and you're good to go. So, hope you enjoyed this video.